Okay, let's do our second lecture on this, really, but our introduction to the idea of externalities. So previously we've talked about sort of broader conservation policy within agriculture. Now let's talk a little bit about the theory, because one, you can look back at the conservation policy that we've already talked about, and you've viewed a lecture and a few discussions on, and think about how do these externality models apply to what we've seen in conservation policy already. And then after this, I'll give you a little reading after you've thought through the externality model on a current problem, basically confined animal feeding, and how to, it's a current problem in that policy makers, communities, producers, production groups are right now still trying to figure out the best sort of policy approach to make this work. Okay, it's the ideal policy means never going to court. That's what somebody once told me, and right now a lot of those cases end up in court because there's just the policy approach on permitting and setbacks and all of these sort of regulations are still in dispute, and it's because we haven't quite reconciled the economics, and the economics determine the economic model required is one of externalities. And so really externalities are a form of market failure. We've talked about market failure being a time to bring in policy, and so that's where we're going to go. So you do have a more detailed reading on this with some examples of supply-demand graphs and welfare that comes after this lecture. So I'm going to just hit on the high points, kind of give you the refresher, and then ask you to read through that and watch their little 4-minute introduction in that as part of that web page or that web course thing. So an externality is just an economic cost or benefit that accrues to someone who isn't a party to the decision making. I'm sitting here, somebody just made a sale, there's a buyer and a seller, and they did it based on those costs, and they did not account for me, okay, because I'm not a party to it. Normally that doesn't matter, but if they made that sale and one of the things that happens is I'm impacted by it, and I end up, we have, we're in pandemic right now, so let's think about that. A county decides to keep all of its businesses open and do everything else, and they end up having an outbreak, and they're not, it's not so bad, but it doesn't really affect me that much until next year. My health insurance bill is now 15% higher because they paid so many claims out for care for COVID-19 that the entire pool, in the health insurance pool, everybody's costs got raised because the payout now is the potential payout is so much more. Well, their unwillingness to do social distancing in this neighboring county, even though I'm not saying they walked by me, they got me sick, they did anything, well, they have an external cost if they do cause everyone's cost to go up in the insurance market, even under fair insurance, right? So, that is the kind of thing we're talking about here. The externalized costs that don't show up in a transaction. And I picked that example mainly because it has an insurance component and relates back to the previous module, but also because, this year that we're doing this, it's kind of timely. Okay, so as you move through here thinking about decision making on those cost benefits, think about always the externality has to be someone who isn't party to this. They don't get the cost or benefit. They get a cost or benefit while having no stakes in the actual transaction or decision making. So conditions on market efficiency, just to remind us of those: complete information, freedom to enter and exit, and then of course complete markets including contingency markets. So you can get anything you want insured, or you can buy an option on anything, if you like to think of it that way. Incomplete markets are a classic externality case. It's typically something like a joint production when we think about agriculture and externalities. So we are making some good A that everybody wants, there's a market for, but at the same time you make X, and that's some externality. And then of course the classic sort of generic term is pollution. We should not ignore that externalities can be positive or negative. Most policies are directed at negative externalities. There are positive externalities, and this asks if you can name one, but we just did a bunch of things we just covered in a previous lecture in this module. All these sort of environmental benefits that farmers can produce, and we talked about the conservation stewardship program, which basically looks for these environmental goods that can be produced on farms jointly with ag production and looks to pay for those. So, and once you pay for them, they're no longer an externality. They're now a public valued good. So there's some others, but you can think through that if you like. Okay, incomplete markets. There's a supply of externalities, and it's tied directly to the market production of those goods and services. And then same thing on the demand for externalities, or sometimes we turn it around and say not demand for the externalities, but demand for the abatement. That means the reduction of negative externalities. It's incomplete because the person that is out there doing the supply of poor air quality or particulates into the air, they exist. They're out there producing some other good jointly with that, and all their incentives are tied to the other good, the non-air quality good. You can't identify them, so even if you were willing to pay them to stop, it's incomplete because you can't complete the transaction. You can't say I have a willingness to pay for better air quality and removal of particulates at the source, so that market is incomplete. It is not solvable, right? And in a practical sense, and that, and not just that we can't do the math, but we can't find, you couldn't practically go out and do this. So that leads to some policy approaches. One is to incentivize activities that promote positive externalities, right? So in this case, promotes abatement, promotes reduction, so you incentivize those. So something like the EQIP program is the policy approach. Or the second one would be regulate or de-incentivize those activities. You impose a tax that causes someone to account for the cost right away, and so that would be the limiting factor. Those are the two approaches. So either you incentivize the abatement side, or you regulate and then tax the negative externality. So certainly fines, penalties for effluent, and so forth are in that approach. EPA stuff, basically. Okay, how do the economics work, though? How do you get to those two solutions being what is in play? Well, the economics say that there's a private cost and a social cost. So the imperfect market that has externality production tied to a specific agent means that that marketable product, the one that actually the market is complete and exists for, will only reflect the private information. Okay, so they're going to choose an optimal production level based on just what the market signals to them, without considering the joint externality that there's no market for. And it's important to realize this is not a simple problem of joint production. It's not the fact that two things are made at the same time, because we know how to solve that problem if the markets are both clear. If they both have markets that can clear. So a producer of wool and lambs is producing a joint product, and they set a production path that maximizes the net revenue of both of those jointly, the joint production system, just fine. And they can only do that though because there are two markets, one for wool and one for lambs, and so that they can make the marginal trade-off decision, right? So it's an integrated production that they can't separate, just like externalities, but the market existence makes it where it can work. So really, it truly is a missing market or market failure problem. So that means economic analysis isn't going to focus really on the joint production, but it's going to focus on these sort of full cost information, right? So just like, what is the cost of wool and lambs jointly? Well, what is the cost jointly of production of anything when you add the external cost to it? Okay, and so the idea being that just because you don't internalize the cost like you do for fertilizer or irrigation or energy on a farm doesn't mean the cost doesn't exist. So let's add it onto the aggregate production or supply curve, marginal cost curve, and get the public goods portion of the public bads attached to that. So just as public goods can be produced non-rival, non-excludable, the same occurs for consumption side, and that's where we get the term public bads. So they all add these sort of social costs, the aggregate. I hate the term social cost because it gets conflated with socialism, and it's not the same thing. But it's the idea that it's a generic term in this case for, we don't know who exactly these costs are, but they will be someone, right? There will be someone who takes on this cost, and it may not be. And the other problem with this is the social cost, sort of as a term, gets people thinking that we all bear the cost equally, right? We all take on a small cost, kind of like the gas tax or something, and that is not the case, right? It is typically geography dependent, risk and other factors dependent. Okay, so how do you do the economics here? Well, you just add the marginal private cost to the marginal social cost on the aggregate production curve, and you get the marginal total cost. Okay, so if you're thinking of this in a supply curve context, where the supply curve, I guess it would be the inverse supply curve, measuring marginal cost, sits there with the private cost, the sort of pure technical cost, add a chunk onto it for the social cost of dealing with whatever the externality is, and you get the marginal total cost. And so the real question is, how much higher or steeper is that marginal cost curve when you add the externality cost onto it? We know it's going to be some higher, and we know that a steeper marginal cost will give a steeper supply curve and a lower output supply for the same demand curve. Okay, so just think of it this way. I guess I don't have the drawer turned on, but you have a marginal cost curve or a supply curve here. The marginal cost curve in aggregate, when you add the social cost or the externality cost to it, will be steeper and up here. And so if there's a single demand curve going through all of that, you're going to be at a lower output level. Okay, so it's basically saying anywhere there's an externality, right, that people don't want to exist, there's overproduction. That's the key. There's another problem here. It's not a single side of the market. It's not the producer exclusively generating the externality. There's a demand curve and willingness to pay for a good in the market as well, in the marketable good. And it turns out the purchasers are also not including in their demand curve the externality. Okay, so you buy this thing that was produced, and as part of the production, this externality was there, and nowhere in your bidding for the good are you bidding for your willingness to abate, right? So you may be the one affected by this, but since the market, maybe I have asthma and air quality is more important to me, and I would be willing to pay it, but it's not showing up in the market. My willingness to pay for this is not showing up in the market because we don't have labels for produced with minimal air quality damage or something like that. Now, certainly markets and labels have started to become a big thing, And part of that is to try to sort of capture that willingness to pay for externalities, maybe in naturally produced or organic, where people have that belief. Those are pretty niche and not great models right now for us to think about. So we're talking about sort of a bigger picture that has to have a policy response. Okay, so the idea then in economics is to get back to an equilibrium where both the purchasers in a market and the suppliers in a market have incorporated on their willingness to sell, which comes from the cost side of the market, and their willingness to pay, which comes from the demand side or the utility side of the market. They're both incorporating this idea that the production as an offshoot or as a joint product or as something that's unavoidable in the current technique produce this thing that is sort of a publicly bad good, right? It's a good that nobody wanted. It is a degradatory effect, and it's common, and so that means to get from the complete to the incomplete market, the pricing has to occur where you're now paying for not just you're producing a quantity and at a price that incorporates that on both the supply and demand side. So we get not only that. I drew a demand curve. Well, I didn't draw it. I just shook this pointer across the screen. A demand curve that has the willingness to pay for the private good, but then you have to draw one up here that has a higher willingness to pay because now you're also paying for the sort of abatement effect. Lower beneath that one. Okay. So you'll see all this in the next reading. I just wanted to go through it with some examples here. An overview, so to speak. So the first 30 pages you might get in a natural resources book. Okay, so let's think about the case of like energy, right? So you hear about clean energy and dirty energy and which one is good and bad. Well, energy is just energy, right? You need a certain amount of kilojoules to move something or to generate heat or whatever. So we don't really care, right, on the energy market side. And so the lowest cost energy, sort of wins, the efficient lowest cost production. But it could be the case that it's low cost because it doesn't have a very efficient transfer, and a lot of waste ends up deposited into the environment in a way that imposes costs that we're not accounting for in the transaction. And so all that externality economics has to say about this, all economics has to say about this is if we do this right, if we're able to incorporate externalities, the sort of true production cost, the sort of true willingness to pay on the demand side to all of this, then we should end up with a case where the marginal cost of the cleanest energy, whatever it is, CE, is equal to the marginal cost of the dirtiest energy, right? The equilibrium should bring us to a point where it doesn't matter. It is just a bid on the sort of the cost per unit of energy production, but it's a full accounting of the cost, right? It accounts for the cost of the things we don't want to make as well as the things that we do, right? And so you might have this sort of clean energy profile that's high marginal production cost, right? So it's actually expensive to make because you have to sort of be getting a full efficient transfer of fossil material or whatever. Maybe it's ethanol based, so that it is it has a lot of bio-based materials in it, cellulose, and so it has sort of a high production cost per unit, but small damage or risk costs in terms of sort of environment or pollution, whatever. And then the dirty energy is going to still have the low marginal production costs, but it'll have the high damage risk cost, right? So the external costs tacked on here make up the difference, so that in equilibrium, CE is equal to DE over here, and we end up with that. Now, it's not as simple, right? So the sort of simple approach would say, well, we just have to price this at least as high as the dirty energy, at least as high as the clean energy, and we have the solution. Well, that's not the case, right? Because there is always external costs, right? So you make the high marginal production cost here, you don't know this component yet, okay? This one's still not accounted for, and also it's not an equilibrium condition unless the market is able to price all four components, okay? And so it is not as simple as saying we just have to price or tax what we believe to be the dirty energy profile is to make it as expensive as the clean energy. That is a crude and inefficient approach, right? It not only it also incentivizes lowering this marginal cost, not mitigating the damage or the risk, right? So it has this sort of perverse effect where it can be expansionary because the information is not complete. Okay, so it's truly a missing market problem. So what do you do? Well, if you can't do what we just said, then it becomes important to think about what the sort of regulatory approach might be. Do you just set limits on what we're allowing and then impose the cost directly? Or do you say everyone that produces energy has an allowance of sort of externality or pollution, and then they trade it, and the market, this is sort of the sort of most often model that's proposed is tradable permits. Give everyone some allocation of pollution that they're allowed to have, make that total allocation hit the policy target for the sort of society's risk and tolerance for health effects, and then have them just trade the permits, right? So this high marginal production but low damage, they're going to have a lot of extra permit or a lot of extra allocation that they're willing to sell to the market. And then the fact that this sort of low marginal production, high damage are paying for these higher allocations means that they're going to be taking on a higher cost than they want, and so it should incentivize technical efficiencies to further lower this, but also technical efficiencies here to lower the cost on this side, since that's the real problem. And so the idea being, if you can equate those marginal costs in the market, doing something like an allocation, giving everyone the right to pollute to some degree based off of sort of the full demand for whatever the externality is, if it's air pollution or if it's greenhouse gas emission, whatever. If you can set the total allocation, then you can get a market effect just by saying every firm that shows up and wants to participate in the supply side of this market has an allocation, and then they're allowed to trade their permits on pollution permits. That's what's been proposed. If it doesn't sound complicated, then it should, because it's a high information cost problem. Plus, of course, we have a lot of private business that doesn't want to participate in something like that. And then, of course, we have the only information missing isn't just the externality. We also don't know the time horizon for damage. We do not know how to turn measured pollution amounts into full economic costs. We do not, that's stuff that's all still there. We know more about the long run and sort of the end of things, like if you get too much greenhouse gas. We know that. We know very little about the time path, the rate of adjustment, and things like that would actually allow medium and short run market adjustments to play out, and so that you could actually design a policy to fit those. Okay, with that, I think we'll sort of leave aside the big picture externality talk, and you'll move into a sort of web reading and a little video, and then I'm going to have you read an article from 2015 in Indiana about someone who's trying to build a confined animal feeding operation, and sort of the perspectives of the community there, and then we'll do a little bit of a discussion forum item for our final assessment this module, where people can sort of weigh in, not on what you believe, who's right or who's wrong, but how might you design a policy that fits this externality model, right, for CAFOs. Okay, so you'll read the two sides. I don't really care about the debate over who has the right to sort of within the law to set up a farm and how close it can be to someone else. That's sort of all going to happen in court right now. But how would you think about this externality model and put it to use for something like the CAFO problem? Okay, with that, I want to sign off here and close out this lecture.